The last of our review sessions covers nth roots and rational expressions. So we previously talked about exponents, right, that can be used to square a number. Now we're going to study radicals which undo exponents, spelling error, and have the number go back to itself. So for example, 3 squared is 9, the square root of 9 is 3, 5 to the 4th is 625, and the 4th root of 625 takes us back to 5. The principal nth root of a real number, as long as n is greater than or equal to 2, is typically symbolized by n square root of a, okay? We call this the radical, where n is our index and a is the radicand. That's what we're taking the radical of. So if I take the nth root of a and get a whole number b, that means b to the n equals a. And here are a few examples. So there are 3 different cases of nth roots. The first case is that if n is even and a is positive, then we say n squared root of a is the nth root of a, and we'd call negative n squared root of a the negative root of a. Now, it's important to note that, you can have a negative root, right? Because negative 5 times negative 5 is 25, and 5 times 5 is 25. So this number, if I was to take the square root of 25, it has 2 possible roots. But typically, we're just asking for the principal, which is this positive square root, which would be 5. If I wanted negative 5, I would write negative square root of 25. The next case is that if n is even and a is a negative number, this isn't a real number, this is a complex number that we're going to cover next chapter. I think this is section 1.4. The last case, case 3, is that if n is odd, then there's exactly 1 real nth root. And if it's odd, you can also take the root of negative numbers. So if I want the square root of 100, that's going to be 10. But if I want the negative square root of 100, that is going to be negative 10. If I want the 4th root of 81, that's going to be 3. If I want the negative 4th root of 81, that's going to be negative 3. However, I cannot take the square root, right, of the even root of a negative number. So this is a complex number, and we're going to skip it for now. But I can take the cube root of a negative number, right? That'd be negative 2, because negative 2 times negative 2 times negative 2 gives me a negative 8. So that'd be negative 2, and the cube root of 8 is also 2. So exponents don't just have to be whole numbers. Exponents can also be fractions. And these rational exponents represent radicals. So if I said 4 to the 1/2, that's the same as taking the square root of 4, which is 2. If I said 9 to the 1/2, that's the same as taking the square root of 9, which is 3. If I had negative 16 to the 1/4, that means I'm asking for the negative 4th root of 16, which would be negative 2. If I had the negative 25 to the 1/2, that'd be asking for the negative square root of 25, which is negative 5. X to the 1/3 means I want the cube root of x. 27 to the 1/3, that's going to give me 3. Negative 27 to the 1/3, that's going to give me negative 3. So let's solve a few rational exponents. 100 to the 1/2, that's the square root of 100, which is 10. 64 to the 1/3, that's going to be 4, 256 to the 1/4 that's going to be, I believe, sorry, I grabbed a calculator. Okay, that's going to be -4, because 4 to the 4th is 256. And 4 cubed is 64. Okay, cool. If I have -32 to the 1/5, now this, right, I can take a 5th root of -32. 32 to the 5th is 2. So the 5th root of -32 is going to be -2. Now, if I have a to the m over n, that means I want the square root, well, okay, not the square root. I want a to the 1 over n, and I can pull out that m. So if I have 4 to the 3/2, that means I want 4 to the 1/2 cubed, which would be the square root of 4 cubed, so 2 cubed, which is 8. So let's work through a couple examples. If I have 36 to the 3/2, that's like saying I have 36 to the 1/2 cubed. That means I have 6 cubed. If I have 125 to the 2/3, that means I want 125 to the 1/3 squared. Well, the cube root of 125 is 5. 5 squared is 25. If I want the -4 to the 5/2, that's going to be -4 to the 1/2 to the 5th. Well, that's going to be -2 to the 5th, which would be -32. If I have 9m to the 5/6, if I have 9m to the 5/6, that is 9m. Oh, that 9 isn't attached, so it's just the 6th root of m to the 5th. If I have 6 x to the 2/3, that's like saying 6 x to the 1/3 squared, so it'd be 6 cube root of x squared. Now, one thing I forgot to mention is rational exponents with negative numerators. If I have a rational exponent with a negative numerator, that's still a fraction, right? So this would be 1 over 16 cube root of 4, right? This would be 1 over 25 to the 3/2, and then it's up to me to simplify it, right? I've got 1 over the square root of 25 cubed. That's 1 over 5 cubed, which is 1 to 125th, right? For this third example here, let me change colors real quick. If I have 8 to the -2/3 over 27 to the -2/3, right? Remember, negative exponents go to the denominator, so I flip it. I've got 27 to the 2/3 over 8 to the 2/3. That's really saying 27 cube root squared, which would be 3 squared. Cube root of 8 squared, which would be 2 squared, so I have 9/4. Same holds true for exponents, for variables as well. I've got 1 over r to the 2/3. The rules for rational exponents, it's important to note, are the same as the rules for real numbers.